Hi friends, today let's talk about the distributive property. This is something that we see a lot when we are simplifying algebraic expressions. It comes up in all different areas, so let's look at it. Distributive property says that if I have a number that is multiplied by either a sum or a difference, so if I have this number a multiplied by parentheses b plus c, I can distribute that a to everything inside the parentheses, and I can rewrite it as a times b plus a times c. And remember that when we write those letters smushed up next to each other, that means multiplication. Now, often we will denote that we are using the distributive property by drawing an arc from that a on the outside to the b with an arrow, and then an arc from the a on the outside to the c with an arrow. Some people say it kind of looks like a rainbow, but you'll often see that same notation to indicate a gets multiplied by b plus a gets multiplied by c. Now, I definitely want to write it out separately just so there's no confusion. This also works if I had a times b minus c. That would be ab minus ac. It would keep that same center sign. All right, so let's look at some examples of what this might look like in your algebra. So if I had 2 times parentheses x plus 1, when we distribute that 2 to the x plus 1, and I would draw that arc, 2 gets multiplied by x to give me 2x, 2 gets multiplied by positive 1 to give me positive 2, and I would have 2x plus 2. That's how we remove those parentheses, and then often that's just one step in the problem. We're going to collect like terms or do something else to solve this problem. Now, sometimes you'll have an x on the outside. So I'm going to say, let's look at x squared times parentheses x minus 3. We're going to treat this just exactly the same. That x squared is going to get multiplied by both the x and the negative 3. Keep in mind that center sign stays where it is. It goes with that 3. So x squared gets multiplied by x, and I'm going to draw that arc with the arrow. X squared times x is going to be x cubed. And then I'm going to draw another arc from the x squared to the negative 3. So I have negative 3x. So instead of x squared times parentheses x minus 3, this would be x cubed minus 3x. Now, if you look at both of these, you may be tempted to then factor out a number, or in this case, an x. Ooh, I made a mistake. Hold on, let's fix that. I have x squared times x is x cubed. X squared times negative 3 is minus 3x squared. Sorry about that, guys. All right, so you might be tempted to factor out where we have 2x plus 2. You might be tempted to factor out a 2 to the outside. And if you did, it would be going back to where we started. Factoring and distributive property are opposites of one another. Factoring undoes distribution, distribution undoes factoring. So they are very closely related to one another. All right, let's look at one more, and then we have one more thing to look at. So let's say I had 2x multiplied by y plus 3x. Because you may see this with all sorts of variables mixed up together. All right, so 2x is going to get multiplied by y, and I'm going to draw that arc to remind myself that I'm multiplying them together. So 2x times y gives me 2xy. Then 2x is going to get multiplied by 3x. So that's going to give me a positive number. 2 times 3 gives me 6, and x times x gives me x squared. Okay, again, you might look at this and say, gosh, I could factor out a 2x, and you'd be right. It would just be going backwards to that original problem. All right, so what if I had 1/2 times 2x minus 3y? And that's 1/2 times parentheses 2x minus 3y. Well, that can get distributed as well. So that 1/2 would get multiplied by 2x. 1/2 times 2 is 1, so we would just have an x. And then we take that 1/2 and multiply it by negative 3y. So we would keep that negative. 3 times 1/2, you could think of this as 3/1. Multiplying straight across, we'd have 3/2, and the y stays with it. So we would have x minus 3/2 y. So this leads me into one other way we see the distributive property that's not always as common, but equally important: division. So if I have b plus c and it is divided by a, this can be rewritten as b over a plus c over a. So over here, I'm distributing the multiplication, and then here, I'm distributing the division. Let me go ahead and write the subtraction one. B minus c divided by a. This would be b over a minus c over a. Okay, still distributive property. Let's look at least 2 problems out of this. If I had 12x minus 4y, and I had that divided by 4, I could rewrite this. 12x over 4 minus 4y over 4. So you could think of it as doing this grouping minus this grouping. So the 12x and the 4 group together, and then the 4y over 4 group together. And then we could simplify. So 12x over 4 would just be 3x. 4y over 4 is just y. So this would simplify to 3x minus y. Let's look at one more. So I have 5xy minus 20x over 5y. And I just threw some extra variables in there for you. All right, so we're going to rewrite this as 5xy over 5y minus 20x over 5y. We can simplify this a bit. In the first fraction, those 5's will cancel, the y's will cancel, and I'll just be left with an x. In my second fraction, 20 divided by 5 is 4, but that's the only thing we can simplify. So we're left with 4x over y. So instead of 5xy minus 20x over 5y, we have x minus 4x over y. This will be important in college algebra as you're simplifying things with the quadratic formula. That's the main place that you'll see it, but it's very important because it's easy to make a mistake there.